Okay, for this one, you are going to need your booklet with your first trigonometry handout. Um, when you'll see at the top of the first page, there'll be these three triangles. Now you'll notice that they are not to scale, but we have said these are similar triangles, which means the ratio between the sides are the same. So if we consider, for example, these two triangles, ABC and DEF, AC and DF would be corresponding sides. And the ratio, so if we said, what's the ratio of AC to DF? Well, that would be 9 over 10.8, or if we simplified it, it would just be 5 over 6. If we did the same thing with the other side, so we have the hypotenuse, which is AB over DE. So we've got 15 to 18. Again, this is 5 to 6. And our last one, which is BC to EF, that would be 12 to 14.4, which is, again, 5 to 6. We can do the same thing with ABC and JKL. You notice 9 to 18, that's a 1 to 2 ratio. 12 to 24, again, you multiply it by 2, and 15 to 30, you multiply it by 2 as well. Now, we've seen that before, probably in past years, but what we're going to do with trigonometry is we're going to say, well, these triangles are all similar triangles. Let's compare the ratios of their sides. So if I take AC and compare it to AB, for example, 9 to 12, is that going to be the same as 10.8 to 14.4 and 18 to 24? So actually, let's consider, first of all, CB to AB, and this is right from the notes, right in the middle. So CB, if we look, CB here, that's 12. AB, the hypotenuse, is 15. And if we simplify that, that's 4 over 5, or we could write it as 0.8. Now if we look at FE, so the same side, that's a corresponding side. Here's the base, CB, and FE here. And we compare it to the hypotenuse of that triangle. So to DE, you get, well, that's 14.4 over 18, which again is 4/5, or 0.8 if you just throw it into your calculator. And the last one, LK to JK, so LK to JK, so again we're comparing the base to the hypotenuse, it's 24 over 30, which again is 4/5, or you could write it as 0.8. So we notice that all of these ratios between the sides of these similar triangles are identical, and we're going to be using that idea in trigonometry, and this is just for right angle triangles, is all we're going to be studying in this course. So if we have a right angle triangle, there's actually a function that links that angle to the ratio of a pair of sides of the triangle. So let's look at ABC here, and we'll list all the possible ratios. So this is again at the bottom of the first page. We're going to list all the possible ratios. Well, we could compare AC to AB, for example. So here, let's just draw a line here, because now we're looking at that example on the bottom. All the possible ratios, we could have compare AC to AB. So this side here, we compare it to the hypotenuse. We could compare BC to AB as well. So the bottom, the base here, to the hypotenuse. We could compare AC, so this side here, to the base, which is BC. So we can make those three comparisons. Now, we can also flip those upside down. So instead of comparing AC to AB, we compare AB to AC. So we would just say AB to AC, because that gives us a different ratio. And then AB to BC, and BC to AC. And we're going to use these 6 ratios are your basic trigonometry ratios, but we're only going to worry about 3 of them for this course, and we will talk about that